reminder session. We all know what a triangle is. A closed figure formed by three intersecting lines is called a triangle. Tri means three. A triangle has three sides, three angles, and three vertices. For example, in triangle ABC, denoted as triangle ABC, AB, BC, CA are the three sides, angle A, angle B, angle C are the three angles, and ABC are three vertices. But the question is, why do we need to study about triangles? Well, that's because the concept of triangles is used in many aspects of our life. It is used to measure the height of a tree. It is also used in the construction of bridges, sloping house roofs, triangular signboards. You'd be surprised to know that triangles are also used in astronomy for zooming in and out. It is also used in carpentry. Today, let us study about certain properties of triangles. Congruence of triangles. So what is the meaning of congruence? Congruent means equal in all respects of figures whose shapes and sizes are both the same. You have seen that two 5 rupee coins fit exactly on top of each other. Two identical photographs look the same. Similarly, two building blocks are identical to each other. Two biscuits of same type are also identical. These objects are said to be congruent to each other. However, a 5 rupee coin and a 2 rupee coin are similar. However, they are not identical and hence not congruent to each other. Now draw two circles of the same radius and place one on the other. What do you observe? They cover each other completely and we call them as congruent circles. But what is the need to study the congruence of objects? Well, there are many applications of congruence objects in our daily life. Sometimes you may find it difficult to replace the refill in your pen by a new one. And this is so when the new refill is not of the same size as the one you want to remove. Obviously, if the two refills are identical or congruent, the new refill fits. Look at these figures shown here. Can you tell which ones are congruent to each other? We can see that if we put triangle 3 over triangle 4, it fits perfectly. Thus, triangle 3 is congruent to triangle 4. Now look at these two triangles shown here. When we turn triangle MNP and put it on triangle ABC, it again fits perfectly. This means that triangle MNP is congruent to triangle ABC. We write this as triangle MNP is congruent to triangle ABC. Notice that when triangle MNP is congruent to triangle ABC, then sides of triangle MNP fall on corresponding equal sides of triangle ABC. And so is the case for the angles. That is, MN covers AB, NP covers BC, and PM covers CA. Angle M covers angle A, angle N covers angle B, and angle P covers angle C. Also, there is 1-1 correspondence between the vertices. That is, M corresponds to A, N to B, and P to C, which is written as P corresponds to A, Q corresponds to B, and R corresponds to C. Note that under this correspondence, triangle PQR is congruent to triangle ABC. But it will not be correct to write triangle NPM is congruent to triangle ABC. This is because the corresponding angles and sides will not be equal. So, it is necessary to write the correspondence of vertices correctly for writing of congruence of triangles in symbolic form. Note that in congruent triangles, corresponding parts are equal and we write in short CPCT for corresponding parts of congruent triangles. Now let us draw two triangles with one side 4 cm and one angle 50 degree. Are they congruent? We observe that these two triangles are not congruent. So, equality of one pair of sides or one pair of sides and one pair of angles is not sufficient to give us congruent triangles. For this reason, we have certain criterion for congruence of triangles. The first axiom of congruence is called the SAS congruence rule. It states that two triangles are congruent if two sides and the included angle of one triangle are equal to the sides and the included angle of the other triangle. In this figure shown here, we are given OA is equals to OB and OD equals to OC. Show that triangle AOD is congruent to triangle BOC and AD is parallel to BC. You may observe that in triangle AOD and triangle BOC, it is given that OA is equals to OB and OD is equals to OC. Also, since angle AOD and angle BOC form a pair of vertically opposite angles, we have angle AOD is equals to angle BOC. So, triangle AOD is congruent to triangle BOC by the SAS congruence rule. In congruent triangles AOD and BOC, the other corresponding parts are also equal. So, angle AOD is equals to angle OBC and these form a pair of alternate angles for line segments AD and BC. Therefore, AD is parallel to BC. It is important to note that so SAS congruence rule holds but not ASS or SSA rule. ASA congruence rule states that two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. Let us now prove this rule. We are given two triangles ABC and DEF in which angle B is equals to angle E, angle C is equals to angle F and BC is equals to EF. We need to prove that triangle ABC is congruent to triangle DEF. For proving this congruence of the two triangles, see the three cases arise. Case 1. Let AB is equals to DE. Now what do we observe? We may observe that in triangle ABC and triangle DEF, we have assumed that AB is equals to DE. It is given that angle B is equals to angle E. It is also given that BC is equals to EF. So, triangle ABC is congruent to triangle DEF by SAS rule. Case 2. Let, if possible, AB is greater than DE. So we can take a point P on AB such that PB is equals to DE. Now in triangle PBC and triangle DEF, by construction, PB is equals to DE. It is also given that angle B is equals to angle E. It is also given that BC is equals to EF. So we can conclude that triangle PBC is congruent to triangle DEF by the SAS axiom for congruence. Since the triangles are congruent, their corresponding parts will be equal. So, angle PCB is equals to angle DFE. But we are given that angle ACB is equals to angle DFE. So, angle ACB is equals to angle PCB. Is this possible? This is possible only if P coincides with A or BA is equals to AD. So, triangle ABC is congruent to triangle DEF by SAS axiom. Case 3. If AB is less than DE, we can choose a point M on DE such that ME is equals to AB. And repeating the arguments earlier in case 2, we can conclude that AB is equals to DE and so triangle ABC is congruent to triangle DEF. AAS congruence rule states that two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. Suppose we are given that a line segment AB is parallel to another line segment CD. O is the midpoint of AD. We have to show that triangle AOB is congruent to triangle DOC. And also we have to prove O is also the midpoint of BC. Now, In triangle AOB and triangle DOC, we have alternate angles are equal and AB is parallel to CD and BC is a transversal. Therefore, angle ABO is equals to angle DCO. Vertically opposite angles are equal. Therefore, angle AOB is equals to angle DOC. We are given OA is equals to OD. Therefore, triangle AOB is congruent to triangle DOC by AAS rule. Now, OB is equals to OC by CPCT. So, O is the midpoint of BC.